Welcome to this Sahara 4 exercise. In this exercise, we will open the Petrophysical data window, which will allow us to visualize all the information that has been imported as Petrophysical data in exercise 8, and also will allow us to modify the outlier value that we detected in the previous exercise number 32. We had one value in the D20 well in the 25 layer that was an outlier, a value that was not valid, and we had to modify it using this petrophysical data window. The petrophysical data window has plenty of other functions. We can use it, for example, to calculate petrophysical data, for example, from maps or other functions that we will explore them in future exercises. But for now, we will use the basic functionalities that will be visualizing the information and doing manual edits. So for that, we will go to our Sahara project, and once here, as we reviewed previously, we can check the values that we used in the previous exercise. We have this D20 value that has a total porosity value in this layer, in this well, of 51, which based on the criteria that we decided in the previous exercise was too high to be considered an acceptable value or a normal value. So in this case, we don't have any replacement as the correct value. So what we want to do is just to erase this outlier, so it doesn't affect our future mapping of the porosity variable in all the layers. So for that, we will go to Edit, and we have here Petrophysical data. You can also quick access with Control K. And once here, we open the Petrophysical data window. Here we have three options to view this window: by well, by data type, and top base. By well will allow us to select here in this selection window. We can select all the wells that we desire. For example, in this example, I will select all of them, and all the wells will be listed in this menu here. And by clicking on any of them, we can check a table will be generated. We'll maximize this so we can see it more clearly. A table will be generated, which in the view by well we will see all the layers as rows and the different variables as columns. And by clicking here in variables, we can check which columns are the variables that are being plotted. So for example, we have here net pay, net thickness, gross thickness, porosity, porosity, top and base of the layer, and or saturation, and so on, with all the variables that we have selected. We can use this variable selection window to modify which variables are plotted. For example, let's say that we don't want to see any saturation here. We will erase the three saturations and the permeabilities, for example. Let's erase this as well, and let's click OK here, and you can see now that these columns that we had previously which included at the petrophysical data level the saturation of oil, the permeability, are now hidden. So it's not that we are erasing the information, it's just that we don't want to see it in the table that we are using to visualize these variables. So we can also modify which rows, which layers will be included by clicking here in the layer selection. Here we can, for example, let's say that we don't want to include these ones because they don't have any data, and now we see only starting from layer number 1 up to layer 53. Here something important to consider is that if you see in this window any variable which the values are gray out, that means that this variable is calculated, which means that it cannot be modified manually, except for top and base, because this is based on the peaks. So you will be able to modify by going here, top base, and modifying it manually in this view. But in the view by well, the top and base variables are considered calculated and they can be modified here. Other variables, for example, poral volume, here PV. Let's do an example. Let's add porosity let's add a porosity here, let's say 20%, and we will click on save here to apply the change, the 20% that we added. And now you can see that we have a portal volume data here, which if we go back to the definition, we can check it here. We have to close this one, we will close it for now. If you go to variables here and look for pore volume as a petrophysical data, here we can see that it's calculated and is defined by the net thickness multiplied by the porosity. So something important to consider as well is that the variables that are type calculated cannot be imported. So in this case, pore volume cannot be imported as a petrophysical data. You have to import your porosity and you have to import your net thickness. And then in this window, when you have all these columns full and all these columns full as well, you will have your pore volume calculated for each case. In the case that you don't have pore volume, for in any case or any other variable calculated variable, it's because you are missing one of the components here. For example, in the layer 1 we don't have neither porosity nor net thickness. So let's continue with the example. We can also let's include more wells here, so we can do more examples here. Let's change this one and change it to data type. Here, this is another way to check on the petrophysical data information. When you view it by data type, you can select the objects that will be plotted or will be shown in the table, the layers, which in this case will be the layers will be rows, the wells will be columns, and the variable is the one that we will select on this selector here on the left. So in this case we are checking all the net pay information that is loaded in the project, which is nothing. But if we go here, for example, to net thickness, here we can see the different combinations of layer and wells where this has been loaded, imported. So in this case we can see that, for example, in the well D1 the layer 2 has a total net thickness of 4.92. We can do the same for porosity, we can do the same for the tops, but remember that the tops are always going to be calculated except in the last view that we will review now. And here you can select which variables you want to have in this list over here. If we, for example, let's add the ones that we erased before, was saturation, oil, water and gas saturation, they are going to be included, and the order in which they have been included will be respected. Check that the oil saturation has been added at the last place because it was the last to be added. In this case we don't have any oil, water or gas saturation loaded yet in this project as petrophysical data, but this may be used in some of the calculations for the simulator. So we will probably use them in the future. Let's continue. We want to map porosity, so let's look for the porosity value that is the outlier here. If we remember, the value that we have doubts about was in the well D20, so we can check it here, D20, this one, and in the layer 25, and here we have our outlier. In this case, as I said, we don't have any replacement, so we will just erase it, and now we don't have any value here. It will be ignored. This combination of layer and well will be ignored for the mapping process. It will depend, the value that we have now in this combination of layer and well will depend on the mapping algorithm that we use in the next exercise, but for now we will leave it blank, so we don't have any data for this combination. Now if we go check in the bubbles, let's close this one temporarily, and we have layer 25 and the D20 bubble. Now it does no longer exist because the value has been erased. So now we used to have a red bubble here, now we have nothing. If we check on the other bubbles, we know that all of them are fine based on the criteria that we defined in the previous exercise, but now the outlier is gone. There is one last thing I want to comment here on the on this window, on the petrophysical data window, is that you have a third way to plot, to show this table, that is the top base. And here this is basically used to modify the different values that you may have on the peaks that are defined when you import the top and base information. This is the only way to quickly modify the tops and base that are loaded in the project. So here they can be modified. In the rest of the views they will be considered calculated. As I said, there are more options here as well. So here, for example, you can calculate new values. If, for example, you have, let's say, a typical example. Let's go to by data type, and here oil saturation. Let's select all the wells. Let's say that you have loaded a map of oil saturation, and you want to have your petrophysical data updated in case that you want to do bubbles or any other calculation on the simulator as well. You can do it by selecting this one as well. You could use, for example, use this calculate option and base it on map values. Then you have plenty of options here for selection. For example, if you want to select, let's say that you want to calculate based on your oil saturation map all the different values that the oil saturation will have for the D1 well. So we will check in each map which is the value that is corresponding to the XY of the well in that layer. So it will calculate all of them. Just by clicking on D1 on D1 here, you will select the whole column, and by using this button here, you will either calculate the selected cell or select all the selected empty cells. You can also erase values or copy or paste them. Copy the entire table to the clipboard if you want, for example, to modify in Excel, and you can also hide empty columns. Another useful tool that we have available here is the massive modification, that we can do it by clicking, selecting cells in the table. You can do it by either clicking, for example, in the column you will select all the D1 cells. By clicking on a row you will select all the C1 layer cells as well. And for example, let's say that I know that my oil saturation is going to be 50 for all the wells in this layer. I can simply select the layer, so all of them will be painted in blue because they are selected, and write 20. And by clicking enter, all of them now have this 20 value on the table. So by doing this, you can add you can do a massive modification with a single value for all the layers, for all the wells, or for all the values. Let's say that for some reason you want to do it, I don't know, 50 here. All the combinations of well and layer will have this oil saturation of 50 saved as petrophysical data. Also, you can do, for example, you can drag here your mouse, and all these cells will be selected, and here you can just write, for example, 35 if you want to do a different value, and now all the selected ones have 35 as the stored petrophysical value. You can delete this with this button, so all of them are now blank. You can copy a value and then paste it, and now this one has to be done manually. Is for massive modification, it's better to use the ones that I showed you earlier. So we will do like this and put 50 here. So now we have all the values again. And in the case that we have, let's say that we don't have any value loaded here, let's just put it on blank. Let's erase everything with this button. Let's say that we want to hide empty columns. I will just erase this one as well by using the rubber here, and then I'm hiding the D1 well, which doesn't have any information here. So we have all these edition tools. I will just for now erase everything because I don't want to load anything for now in oil saturation. And remember to to apply the changes, you always have to click on save here, and the changes will be considered. You have other options as well. For example, you could use equations for calculation here. We will work this in more detail in a future exercise, but just for you to know that it exists, you have different equations that will be used in each different combination. Well, oil saturation doesn't have any, but for example, if I go to top base and I want to calculate the bases, I can select all of them for all the different layers. I'm checking now for this well, and I can now go to equation and define that I want to use. For example, I want to calculate all the bases as top minus total thickness, and it will do the calculation for me. If I want to do it, I don't know if this project, I don't think it has total thickness, but let's check. I will do an example, a quick example here. Yes, gross thickness, and that base the one that we don't have any value. So let's say, for example, D20 is the sixth layer. Let's go here. D20 layer 6. We have base, but let's say that we don't have it. I will erase it, and I will recalculate it using the equation. So now we have calculated the equation selected here, and we have that the base is the top minus the gross thickness. So we have to save the changes that we did, and now we will do the calculation on the selected cells, and now we see that we have calculated the base of this layer in this well by using the calculation option. So the calculation available that you have plenty of options here. You will have different options depending on which variable you are selecting. If I select this column, we can see that now the options have been modified. If I go to the other view option here in data type, let's save here. For example, for air saturation I don't have any equation available, but for gross thickness I could do the difference of top and base and use that to calculate the different values in each combination of well and layer. For porosity we don't have any available, but it will depend on the different variables that you have selected. For example, here for net thickness you can use a net to gross factor that you can load as a petrophysical data as well, and so on and so on. So what is important here is that we can use this petrophysical data window to visualize the petrophysical data that is imported in the project, to modify it by using the different edit options that we have reviewed so far, the massive modification, the copy and paste buttons, the erase button as well. We can also calculate the different variables that we have available in the project by modifying or using together other variables that we have available loaded in the project. So this is quite a potent tool, as you can imagine, and we will use them plenty of more times in the future. But for now, this is a first introduction for it, and I think it will be enough for this video. So thank you for watching, and I hope you have a great day.